Okay, on this problem it says that he's driving home to his college dorm, or from home to his college dorm. At 4 o'clock, he's 260 miles from home. At 7, he's 455 miles from home. Graph the line that represents Justin's distance from home at a given time. So we're going to do a little graph. And we're measuring two things. We're measuring his miles from home, so his distance from home, and his time. So it just makes sense to put time on your x-axis and distance on your y-axis. So if we let time, let's say that we've started this at 12 o'clock, we could say 1, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6, and 7. And then on this distance, we got to go all the way up to 455 miles. So to me, it makes sense just to let everyone be 100. And then we only have 2 points. We have at 4 o'clock, he's 260 miles. So at 4, put a point about where 260 would be. And so that point, that ordered pair would be 4, 260. And the other point is at 7 o'clock, he's at 455 miles. So at 7, go to 455 and put it. And it says to graph the line. Well, that's 2 points. So to make our line, we're just going to connect those 2 points. And there's our line. Now it says find the slope and interpret it. Alright, remember slope is rise over run, or you could think of it as y2 minus y1 over x2 minus x1. So if we look at our 2 points, if we subtract our y's, then 455 minus 260 over subtract your x's, so 7 minus 4. Alright. So 455 minus 260 is 195. And then 7 minus 4 is 3. Well, that will reduce to 65. And we also need to interpret the slope. You don't want to just do a number. You need to interpret it. What does it mean? Well, what units did we have on our y's up here? That was our distance, so that's in miles. And on the bottom, that's in hours. So really, we have miles over hours, or in other words, miles per hour. So basically, he was driving 65 miles per hour. And that's how you interpret the slope of that line. Okay? Alright, another thing you need to know is that parallel lines have the same slope, and perpendicular lines have slopes that are negative reciprocals. So if you want really simple terms, for perpendicular, it means one is positive, one of the slopes is positive, and one is negative. And basically, to get from one slope to the other one, you have to flip it. So in other words, if one slope that you're looking at is 2/3, and the other slope that you're looking at is negative 3/2, then those two lines would be perpendicular. Okay? Because one is positive, one's negative, and you do flip it to get the other one. Okay? Also, if you had one slope that is 3, and the other slope then that would be perpendicular to that would be the negative reciprocal. So change the sign and then you flip it. If you take 3 and flip it, it becomes 1/3. So those would also be perpendicular. Alright? Parallel have the same slope, so that means, you know, both the slopes were 2, or both the slopes were -1/5, or whatever. But they're the same for parallel. And then on the next one, it says, graph each pair of lines and use their slopes to determine if they're parallel, perpendicular, or neither. Okay? So I do want you to graph your lines. Okay? So to graph your lines, you need to graph the 2 points. U is at 0, 2, so that means you go over 0, up 2. V is at -1, -1, so left 1, down 1. And then draw your line through there. X is at 3, 1, so that means you go over 3 and up 1. And Y is at -3, positive 3, so to go left 3 and up 3. And draw your line there. Alright, now to actually decide if they are parallel, perpendicular, or neither, you need to look at their slopes. Okay? So the slope of UV, you're just going to use your formula and plug in. So you need to basically look at these 2 points and call them x1, y1, and x2, y2, and plug into your slope formula. So -1 minus 2 over -1 minus 0. And that's going to give you -3 over -1, which is a positive 3. And then look at the slope of xy, and you get a slope of -1/3 there. So they are indeed perpendicular, because those are negative reciprocals of each other. You just flip it and change your sign to get the other one. So they are perpendicular. And what perpendicular means, if you don't remember, perpendicular means that they meet at a right angle. Not that they just intersect, but they intersect at a right angle. Alright, on the next one, we're still going to basically graph your 4 points and your 2 lines made by those 4 points. Then you got to look at your slopes. So look at the slope of GH. The slope of GH is 1. And then the slope of IJ is -2. Those are not negative reciprocals, so they're not perpendicular. So that would be neither on that one. Alright, here's another one. Graph your 4 points, so your 2 lines. And then you look at the slope. The slope of CD is 2. The slope of EF is also 2. Since they have the same slope, then yes, they are parallel. Alright, again, we're going to graph these two lines. And when you graph them, you see that they're a horizontal and a vertical line. Well, a horizontal and a vertical line are perpendicular because they do intersect at a right angle. Now, the slope of WX is -3 over 0. You don't need to leave your answer as -3 over 0. You need to go ahead and simplify that. -3 divided by 0. You can even punch it in your calculator, but you can't divide by 0, so that's undefined. And then the slope of YZ is 0 over 6, which is just 0. Okay? So basically, we have one line that has a slope that is undefined, and we have one that has a slope of 0. Now, they're not really negative reciprocals because, you know, you have none undefined. You can't really flip that over. You can't flip 0 over either. So you need to know when you get undefined and 0, that's a vertical and a horizontal line. So yes, they are indeed perpendicular. All right, here's one more example. Graph your 4 points, find the slope, and they're not negative reciprocals, so it's just neither. One more. Slope of that one is 2. Slope of the other one is also 2, so the lines are indeed parallel because they have the same slope. All right, this is your assignment. It's page 186, 1 through 22, and 27. You can skip number 18. I do want you to graph the lines, and I will provide a graph paper for you. Have this completed when you come to class on Thursday.